Okay, doing one last little talk about law of sines. There's another ASS triangle where we have an angle. This one's an obtuse angle and a side and another side. And if A is less than B or equal to B, it's not long enough to make a triangle. So I'm going to show you that. Let's say I make this A. And if I make it exactly the same size as B, it can't make a triangle. It's right on top of it. There's no area inside the triangle. So it has to be longer than B to work. So this would have no solutions, and this would have one solution. So once again, the A angle side triangles can become a pain in the butt. All right, moving on to, everybody get to this slide right here where it says law of cosines proof. I'm going to pause for just a second while I get mine cleaned up. Okay, I'm not going to do the whole proof for this thing because it takes about 15 minutes, and as I explained before, I need to get you through all of law of cosines today, so I'm not going to prove it, but I'm going to try to show you generally why it works. Do you get that the long side of a right triangle like this guy has got to be called C, so that a squared plus b squared will equal c squared? You know what I'm saying? All right, let's make this C, let's make this A, and let's make this B. We're just using that right triangle. So you remember this as a squared plus b squared equals c squared. And why did I put a big gap in between them? Because the law of cosines starts with that. But then there's something more that has to be added. A squared plus b squared equals c squared is great, and it always works for right triangles. But this title of this whole chapter is non-right triangles. So do you get, if I make the angle just a little smaller than 90, but I keep B the same size and I keep A the same size, but I make the angle there just a little less than 90, like 88 or something, a little less than 90, do you get that c squared has to get smaller? Okay. So c squared is all of this stuff. This distance now has got to be shorter. See, it's shorter than it used to be. So this has to get a little smaller. How much smaller? Exactly, you subtract this much from it, minus 2ab, and then take a wild guess which function we use. Cosine, because it's the law of cosines. Cosine C. That green part is the new thing you have to memorize, because you already knew a squared plus b squared equals c squared. But now it's a squared plus b squared minus 2ab cosine c will equal c squared. Now this is really, really important. Do you get how this side right here, that's a little c, and this is a side, and this is a side, and this is a side, and a side? That's the only angle in this whole formula. Do you get that you're usually going to be given one angle and two sides? Okay. So, do you get that this has to go with this? Those have to go together. C goes with C. That makes sense, right? All right. So, what if I made the angle bigger than 90? And I say, okay, so now it's just a touch bigger. A is still the same size, B is still the same size, but this is now 91 degrees. Do you get now how C has to become just a little bit bigger? Do you think we need to change the formula? No, it's actually an awesome formula, so it'll change itself. How on earth could all of a sudden this turn into adding something without me having to change the formula? Yes? The cosine of 91 degrees is a negative. I want you to prove that. You're going to need a calculator anyway. Grab a graphic calculator, type in cosine of 91. I bet you'll see that it comes out to a negative. Cosine of 91 in this case, it comes out to 0.0, what? 0.017, except negative. Notice that negative, along with that negative that's already in the formula, turns that into adding a little something, doesn't it? All right, so I just want to show you why this formula works. Instead of just saying, here's the formula, trust it, I want to show you kind of why it works. Okay. Now, one more thing that's kind of important about this formula is that you can rewrite it. And right now it's solved for c squared. Ooh. Hold on. Okay, but I'm going to rewrite it and then see if it makes sense to you. What if I wanted it to not be solved for c squared? Oh, question?
Well, if it's sine angle sine, can't you use the law of sine instead of having it do a different?
All right, good question. Why can't we just use the law of sines? That's a great question. Let me just show you that answer first, and then you can ask your question. And it is, but thank you. Okay, so why can't we just use the law of sines? It's a really good question. Here, a over sine a, oh, big A, b over sine big B equals little c over sine big C. This works awesome if you know 3 out of 4 things in a block like this. If you know 3 out of the 4 things in the block. But what if you know, like for instance, if you know this one and you know this one and you know this one, you can solve for B, right? But what if you know 3 out of the 4 things, but it's like this, you know this one and you know this one and you know this one? Then the law of sines can't work. See what I'm saying? If you don't know any that go together, if you don't know any angle that goes with a side across from it, then it won't work. Law of sines is useless for you. All right. Back row. Poke. All right. Good. So now, that's why we can't just use the law of sines for everything. All right. So instead, we have to use this law of cosines because, like, let's look at this problem. The problem that we have, actually, yeah, I don't have a problem on the screen right now. If you take a typical homework for question for today, it's like this. They're going to give you these 3 things, and they wouldn't have been able to solve it with law of sines. All right, so how about another combo that you couldn't do with law of sines? What if I give you this side, and this side, and this side? Do you get how the law of sines wouldn't have worked? But we can do the law of cosines. So if I give you the 3 angles, sorry, not 3 angles. If I give you the 3 sides in a triangle, we can figure out how big their angles must be, even if it's not a right triangle. The one we can't do is giving you all 3 angles. Think about that. Let's say I said it was a 45, 45, no, that doesn't actually work. Or no, what's the 3 that are the same? 60, 60, 60, 60. Here, I gave you all the angles. Can you tell me how long the sides are? You know what I mean? There's a lot of possibilities. We just know they're the same. It could be an 8, 8, 8. Could be a 10, 10, 10. See what I'm saying? If I know all 3 angles, can't figure it out. But if I know all 3 sides, law of cosines works. Okay, so law of cosines, this new one for today, is huge, really important. Everybody, hopefully you can memorize that. All you really have to memorize is minus 2ab cosine c. So now, some things that come up, people ask, good questions. They'll say, well, if I've got a problem, how do I know which side has got to be C? In the old days, it was easy because you could just look at a right triangle and the longest side was the hypotenuse, and that was always C. And then the other 2 could just be either one. You could pick A or B for them, right? But the longest side had to be C. We don't have a rule like that anymore. Here's example 1. Everybody get to example 1. Yes, sir. The angle C is going to be across from whatever side you pick to be C. Just wait. One thing at a time. Look at example 1, please. I think after I do this, you'll understand. Okay, so do you get that these are not right triangles, and therefore there is not a side that has to be C? You can pick any side you want to be C. Okay, so if I decide I want this one to be C, well, then it's C. And I want this one to be A or B, doesn't matter. I want that to be A, it's A. And if I want this to be B, it's B. I can pick anything I want, but there is one of them that will work the best for the formula. Hopefully, you have that formula on a different page, because right now I'd like you to try to remember it while it's still fresh in your mind. Write me the formula again. A squared plus b squared. Try to write the rest of the formula out. Write it all down on this problem right now. Recalling it once right now will really help your retention. And then if you do it once more within the next 24 hours, you'll probably remember it for like 3 days. But then honestly, that's not enough to bring you through the long weekend. Most of you guys, if you don't do something over the weekend, you hit Tuesday after the long weekend and you won't remember the law of cosines anymore. So that's one of the reasons people do homework. It's because it helps set things in your mind, because if you touched it again within the 3 days after you learned it the first time, then you'll get to keep it for another week or so. It starts to be longer and longer periods. Okay, did you say minus 2ab cosine c is all equal to c squared? Raise your hand if you had that right. Okay, good. Now, I'm going to tell you which side you want to find out. Because do you get if this is a real world problem, you may not need to know this side and this angle and that angle. Okay, you might just need to know one of those things. So if I want to know this side right here, if that's the side I want to know, what should I call it? C. Okay, that's C. Now, did I pick that strategically? Yes, I did. Because it's across from an angle that I already know. Being across from that angle means that my formula is going to work really nice. I'd like you, if that's going to be C, and again, it doesn't matter if this is A or B, but that's all be the same so that when we put the numbers in, it'll look the same to you. What do you guys want that 13.5 to be? I had somebody say A, we're going with A. That's going to be A, and this is going to be B. Okay, everybody choose it that way so that our answers are all the same. But again, you could have picked anything you wanted. It's just you might end up solving for something you don't want. If you had picked it differently than this, you won't get this as your answer. We're going to find this by setting it up this way. All right, so would you please type the numbers in? It's a little bit of a pain. You got to take big numbers and square them, and you get this long decimal answer. And then at the end, remember that this formula says squared. How do you get the C alone? Square root. Yes, sir. If you have two angles, it's not hard to figure out the third angle. Would you agree with that? So by giving me two angles, you're really giving me all three. So if you have all three angles, and then all of a sudden you got all three angles and you got one side, now you got an angle on a side, you could solve anything. Okay, but then you also could go back to law of sines then. You know what I mean? You wouldn't, see, at that point, if you had two angles and a side, then law of sines is way easier. Okay. Right now you are solving for C. I'm going to pause for a second while I pair you with somebody, and then you can check your answer against theirs. Okay, for the people at home, we have solved number one, and it came out to 9.8. Here's how we did it. A was this one, was 13.5 squared, plus B, which was 16.7 squared, minus 2 times A, which was 13.5, times B, which is 16.7, times cosine of C. That's cosine of 36. Equals C squared. That's just a great big number. And at the end, you take the square root of it, and you get 9.8. Why do you take the square root at the end? Because you're trying to get the C alone. Okay. How many of you guys are done with the second problem? Only a couple, so I'm going to give you a minute. Try to finish up that example 2. Okay, so here's how I'd start exercise 2. I said I wanted to know that question mark, right? If I want to know that question mark, I should set the question mark and the one across from it to be on my C. Do you understand why, if the question mark is the thing I want, that I should set it to be C? Because my formula is solved for C. C is the one that's alone. So a squared plus b squared minus 2ab cosine C equals C squared. See how C is the one that's alone? So that's why if C is alone, then if I want this one, I should call it C. So that's angle C, big C, and this is little c. Okay. So I've already got the little c is 24.1, so that goes here. And I've got a squared, which is, well, I could pick either one to be a or b. I'll pick that one to be a, this one to be b. It won't really matter because they're just going to get squared and added. Okay, and here they're just going to get multiplied. So if you reverse them, it wouldn't matter. All right, so I have a really complicated equation with just basically a whole bunch of numbers, but I just have to solve it. So solving equations by now should be totally in your wheelhouse. But you get it down to cosine C. How do you get it out of cosine? Inverse, very good. So I have no clue what 24.1 squared is, or what all the other numbers are. But can you tell me when you got it down to cosine C was equal to what? What did you get? Cosine C was what? Or did you just go right from there to the answer? Maybe you did. Anybody have the decimal? You got the decimal?
That's the answer.
Oh, that's the final answer. Okay. C equals 113 degrees. All right. Well, thank you very much. Negative 0.39. Okay, so then I do inverse cosine of negative 0.39, 113 degrees. Cool. All right, raise your hand if you had that one right. Okay, cool. Now, do you get that we have one of our three angles now? I'm not going to make you do it again, but do you get that you could do it again with law of cosines, or even smarter, law of sines? Because now we've got an angle that goes with a side. And if we have an angle that goes with a side, law of sines works really well. And it's faster, much faster. No gigantic problem to take a gigantic square root of and all that stuff. Okay, cool. You get it. That's what you needed to learn. That's the only thing that there is. So now we're going to go actually do your homework problems starting now. Which days did we have to do? Days 1 and 2. Okay. What do you have to be really done with for tomorrow? Only the top 20. You could get nothing else done except the top 20 and be okay for tomorrow. But then tomorrow in class, you're going to work together. I encourage you to work in groups, and I encourage you to work in the same groups that you're in right now. But if there's people that mutually want to like add somebody to their group, that's okay. If you're leaving somebody alone, make sure they have somebody they can work with. All right. You guys can just be mature about being in groups tomorrow. Yes? Good question. Law of sines, law of cosines does beg the question, is there a law of tangents? I bet there is, but I've never heard of it and never had to teach it. So go ask the wonderful World Wide Web. Mr. Google will tell you. Have you ever seen If Google Was a Guy?
Oh, yeah.
So I'm sure he's been asked that question. All right. So let's get to the homework and actually plow through one of those together here. Remember I said it was a labs we're skipping and stuff. There we go. Day 1, law of cosines, new problems. Okay, so on this one, you get to label it, and you even get to put the numbers where you want to in the picture. So let's kind of agree on what we think goes logically together here. All right, well, do you get that this is the angle for C? That cannot be the angle across from A or B. By now, I hope you have learned that that little symbol right there is the Greek symbol for C. All right, so now A is a side and B is a side. Which one do you guys want to make 7 and which one do you want to make 12? The top, here, I'll call them the top, the left, and the right. Which one do you think should be 12? Right should be 12? Okay, we can do it any way you want to because it's gonna work out. It won't matter. I'm gonna call this 12. Okay, the top one. What do you guys want the top one to be? C. All right, and that goes with this 59. That doesn't look like 59 to you? That's true. It is a little bit bigger than 90. Maybe we should make this one be 59. Doesn't that look like the most likely to be 59.3 degrees? Okay. And if it is, then the 12 can't be there. All right. So then the 12 and the 7 have to be here and here. Which one? Well, now it's logical. This one has to be 12, and this one has to be 7. Okay. There we go. Now I got a picture drawn. I hope by now you're starting. I heard somebody just say it this morning. Once I have that picture, it's not that hard. Okay. So now you want to find all the remaining sides and angles. Do you get as soon as I have another angle here, I could switch to law of sines? And there's nothing wrong with that. I know the directions say use law of cosines, but once you find another angle, it will be fairly easy to use law of sines. That's what I'd probably do. Okay, so let's find this red angle right here. So if that's the angle I want to do, that's what I'm focusing on. Do you get that those, the red ones I just circled, should be which letter, A, B, or C? If I'm focusing on those, find those, might be. Okay. Oh, I know what you're saying. You're saying that this is big C, and therefore this is C. And therefore it has to be either A or B. Okay. Now that's an interesting note, because this is something we didn't talk about before, but it's true. This equation can be rewritten. A squared plus B squared minus 2AB cosine C equals C squared can be rewritten. Because do you get right now what we're going to end up getting if we do it this way is we're going to end up getting that side because we picked it to be C, and C is the one that you're solving for. So here's the way to think of it now. In right triangles, C had to always be the longest side. With law of cosines, C should be the side or angle that you want to find. Okay? So I guess the way we've got it set up, we may as well find this first. And once we've got that, again, we'll have a side going with its angle, and then law of cosines would be way easier. Sorry, sines. Law of sines would be easier at the end. Okay, but listen, please, if you can. I know we're getting near the end, and it's been difficult to pay attention this long, but you can rewrite these formulas if you can handle the math of it. Do you get, if I want to solve for B squared, then do you get what has to change? This has to be cosine of what? B. This would not be A and 2A and B. It would be 2A and C. This still has a negative in it. And this can't be A and B because we already got the B there. What's this got to be? A and C. Now, some of you that were paying attention there have a little advantage over everybody else because you'll know how to rewrite these things. All right. And there's a reason why if you Google this thing, you see, when you Google law of cosines, you'll see a giant list of formulas. You won't just see the first one I gave you. You'll see a list of them. It'll be this one, the red one, the blue one, and then I'm going to make it the green one. And of course, that one I'll solve for what? A squared. And then this will be cosine of A. And this will be 2 and not the A, B and the C. And this will be not the A and the B because I already got the A over there. So it has to be the B and the C. There's your 3 permutations of this formula, and you can use any of them. But if you just memorize the first one, the other ones you could reconstruct later if necessary. Okay, I know that was a really intense day, but the good part is you do have all day tomorrow to work on this in groups. If you get stuck on things, you can ask other groups. Are you guys getting this? How do you do this? You do have a math teacher here. I don't know if they have done law of cosines, but I'm guessing they probably will have. If you tell them the law of cosines, I bet you this math teacher could help you with a problem too. You just have to remind them what the law of cosines is, because most math teachers might have forgotten that over the years. All that's hard is the negative 2ab cosine c in the middle of it. But okay. So I did cut this assignment down because I didn't assign day 3. All right, so you've got day 1 and day 2 problems, and you have until Tuesday to get it done. Okay? Any questions? All right. So now we got a little bit of work time at the end. Not much, but and if you want to come up and ask me questions and stuff, you can do that at this point.